All right, so the purpose of this video is to demonstrate how to work through some of SE1, which stands for static electricity. And these are just some real basic questions. It's going to, this set here, it's basically going to tell you you have a bunch of extra electrons, and by a bunch I mean a lot. Or another question might be a bunch of extra protons. The process is exactly the same for calculating the actual coulombs. It's just basically a conversion, and then it's a logic thing to determine whether it's if it's positive or negative. We'll start with the logic thing. If it has more electrons, it's more negative because electrons are negative. If it has more protons, it's more positive because protons are positive. Now, secondary, this just a kind of a logistical thing here. This says no plus or minus signs. Beware of that. What that's meaning is don't put plus or minus signs here in the quantity of charge. You certainly may need to put minus signs for coulombs because you're getting times 10 to say the negative fifth or something like that. And so you will need negative signs here. The no negative signs is for this, this region here. Now to actually do the calculation, this is really a conversion. If you remember from chemistry, conversion factors, or when you're doing stoichiometry, sets it up and sort of shows you how to do it. But if an object possesses 1.94 times 10 to the 15th, it has a bunch of electrons, extra electrons, and we say, well, how many coulombs is that? And to do this most effectively, you just need to have a conversion factor. And so this was in the slideshow that you had for your notes. And this is the conversion factor, and this is actually sort of the same thing. In this top conversion factor, it says 1, and this E minus, this means an elementary charge. 1 elementary charge is equal to 1.6 times 10 to the negative 19th coulombs. This is a conversion factor. This is a tiny, tiny, tiny number, obviously, because it takes a whole bunch of electrons to equal a coulomb. And that's shown right here. This is just the same thing, but instead of being 1 elementary charge, here it's 1 coulomb. And it says 1 coulomb is equal to 6.25 times 10 to the 18th electrons, or you can think of that as basically elementary charges. So these are the same thing. They're conversion factors. You can use these when you do a dimensional analysis. And so this exact question right here, 1.94 times 10 to the 15th, it could be set up two ways, and this top way is one common way. So you start with what you have, 1.94 times 10 to the 15th elementary charges. And then you're going to want to get units to cancel, and so you're going to put this elementary charge on the bottom. All right, I could not find my pen. So you're basically going to try to get units to cancel. So since we put elementary charges here, then before we would actually do this, you would say, well, if I want to cancel them out, you could say, well, what does 1 elementary charge equal? Well, it equals 1.6 times 10 to the negative 19th coulombs. And that's where this number came from up here, because these two things are equal to each other. Now doing canceling units and the way variables would work within fractions, you'll know that you can actually cancel out the elementary charge. All you would be left with was this unit of coulomb. So you could multiply this giant number by this tiny, tiny, tiny number, and in fact you're going to get an answer in coulombs. I'm not going to do all that for you. I'm hoping that you have a basic understanding of that by now, although I'm going to add one detail later. Now, there is another option that you may prefer, which is also works just fine. We can, if we pretend we didn't know what that was, or this, if you just said, well, we know we want elementary particles, elementary charges down here, and we know we want to get to coulombs here, you could go back to your conversions. Remember, these are the same thing. One is just for 1E and one is just for 1 coulomb. He said, well, instead of making it 1E, let's make it 1 coulomb. So you can put 1 coulomb up there. And what does 1 coulomb equal? Well, as we show here, it's 6.25 times 10 to the 18th electrons, which is where this number comes from. And in this case, you're taking a giant number. I should show units would get canceled. These would get canceled out in the same manner. All you're going to be left with is coulombs, which you want. And you're going to take a giant number and divide it by an even bigger number. And you're actually going to get the same answer over here as you would have gotten up here. There's two ways to solve it. Obviously, both ways work. It is worth being aware of this process, because this process is a universal process when you're dealing with the conversion, and it's worth understanding this process, I believe. So I've got Nigel here, my faithful calculator for over 20 years now. And I want to point out, when you're doing these, the number one mistake I see students making every single day, and that is a lack of parentheses. So if you're trying to do a calculation, let's say you're wanting to do this bottom calculation where you take a big number divided by an even larger number. This is pretty basic stuff, but there will be many of you that will mess this up, even though I say this, but maybe this will catch a few of you. So I'm going to pause this and show what you should input into a calculator. And what I put in here so far, and what's really important here, notice I did opening parentheses. 1.94 times 10 raised to the 15th in a closed parentheses. It doesn't take long to do parentheses. Sure, sometimes they're not necessary, but sometimes you're confusing your calculator, and just put parentheses around actions. We know this is a thing here. We just put parentheses around it. It doesn't mess up the calculator, but if it's not there, sometimes it does. And so just put parentheses around it. And then it's a good idea just to hit equals and then use the answer for the next thing. But you also, for the purpose of this, I'm going to show, then you can say we're going to divide by, and then put open parentheses, and then do this next thing. Put parentheses around it. Parentheses, parentheses, parentheses. This will catch so many mistakes. And sure, it's faster to not put parentheses, but when you get it wrong 3 times in a row, and then you have to ask for help, and then you're told to put parentheses around it, it would have been faster just to start out with parentheses. So we'd be 6.25 times 10 raised to the 18th, close parentheses. And then we're going to get our answer that we're wanting here. Now, if you're not sure how this would work, this would be 3.104 times 10 to the negative 4th. If you're not sure what that would look like, 3.104 times 10 negative 4. Now, when you go back over here to the actual thing itself, you would enter in 3.104 times 10 raised to, and this is where you would still need to show that negative 4. Even though it says no negative signs, it's talking about here. Thank you. I hope that helps, and have a great day.